everybody. I'm just on my power school, just making catching people as they come in, so it's not as overwhelming when we do our check-in question. But hi everyone, good afternoon. I hope you all had a good break, and welcome to your last period class of the day. So yay, it's just one more, and then you get to relax a bit, unless you have some asynchronous work to catch up on. But okay, let's jump into our check-in question for today. Our check-in is, what games do you play for fun? And by games, I mean like it could be anything, such as like card games, any video games, board games, etc. You can even think about the times when we were in session in class, like at the actual physical school. Some of you are there, but I mean, when we all were there, like sometimes the teacher had games and you'd be excited to play them, things like that. So go ahead and put that in the chat for me as I'm letting more people in here so I could double check on our attendance, and so forth. Okay, some games. Heads up, 7 up. Oh my gosh, is that like I wonder if you mean the like the ones we play when we're children? That was fun. Or there might be another game. I don't know. There probably is a card game that I don't know about because I immediately was thinking that game from kindergarten, I think. All right, let's see. Mancala. I don't know what that is. Board games like Monopoly. We got a lot of Uno fans. I play this video game called CSGO. I think CSGO. Poker. Never played poker. It looks always interesting when people are playing that though. You have to have like a poker face, is what I hear. I feel like I would not have a good poker face. I feel like my face will give off a lot of clues. All right. For those that just came in, we're answering this checking question like, what kinds of games do you play for fun? This could be like any kind of game, card game, board games, video games. Yeah, I haven't played a lot. Yeah. I'm going to have to look these up and call it because these look fun, especially during quarantine. There's like a lot of, board games. Have some more fun. Genshin Impact. I hope I'm saying that right. Genshin Impact. It's a video game. COD, comma 2K. So those are games. I play GTA and Madden on PS4. GTA or Fall Guy. Oh, okay. Pool on my phone. I always be seeing people. I remember like in the bar, people would be playing little pool on their phone. A card game called 500 Mancala. So Mancala was mentioned twice today. Jenga and Monopoly. Yes, I like Jenga. I love that when playing with a group of people. All right, we had a few more that just came on in. And for those who just came on in, we are answering this check-in question, which is, what are some games you play for fun? This could be board game, video games, card games, any of that nature. Especially if you just came in, because I still need to double check the attendance. Okay, so let me see. Let's see if there's anyone else. I know I'm missing like 2 people that just came in. I like Minecraft. I don't know why it's fun to me. Man, so many of this I have not played, so I don't know. I don't know. For some reason I'm like really into old school games. So I have like a Super Nintendo and when I was younger my brother would play on the Super Nintendo. He wouldn't let me play, so I would just watch him play. And so now that I'm older, I got my own Super Nintendo and I like playing the very old school games on there. So, yeah. That's where I'm at as far as games. All right, let me go ahead and check attendance. Again, there could be errors, so please let me know if you're actually here. I'm missing Justin. Yeah, I'm missing Justin. I'm missing Natalie, Rainy. Uh, no, we got Rainy actually. Just now. We're missing Jayla. Again, if I have an error, let me know. Yeah. Do we have Jayla? I don't see Jayla in the thing. Okay. Ernesto's missing. Um, who else here? Jonathan. Angelica. We're missing Angelica. Yeah. So if anyone's friends with Angelica, we can send her a text again. It might be confusing. Amara and Cassie and then Sakaya. So that's who we're missing. Again, if I said your name, if you could please let me know that you're actually here would be great. So again, that's we're missing Justin, we're missing Natalie, we're missing Ernesto, Jonathan, Angelica, Amara, Cassie, and then Sakaya. So that's who we're missing. Actually, I see Natalie right here. So Natalie's here. So I see you. And Angelica's here. I knew that must have been an error because I'm like, we're always here. Thank you. I got you, Natalie, and I got you, Angelica. Awesome. So I'm going to go ahead and hit submit now on the attendance. I made that correction. All right, awesome. And then card games. Yeah, for sure. Thank you all for sharing the different kinds of games you play. I just know whenever if we ever get back into class, I'll know what kind of games to buy. Sorry, I'm just messaging. All right, so let's go ahead and check out our agenda. So actually today, we're gonna just be finishing up the Desmos activity that we started on. I don't think we're gonna get to this other part until next week. Monday is MLK Day, so we're not having school Monday, according to what I know. I'm hoping because we all need that break. So the next time we're gonna continue off on Tuesday. Asynchronous is number 3 is posted and it is due today. Now, for those of you who already taken a look at it, you might notice it's different because it's not a Khan Academy practice. So usually for those who were stuck, you could be able to kind of get some help. Now this is going to be different. Now for this, I don't want you to stress because I know I don't have office hours today due to the structure of things. So what I'd like you to do is instead just try your best and answer the questions. As long as I see you trying your best, answering the questions, just go ahead and submit that because we're going to be talking about it back in class next week anyhow. So just try your best and don't stress too much about being right or wrong. So that's just my 2 cents on asynchronous number 3. I still need to grade asynchronous number 2. So for those who are waiting on that on Power School, it should be in by the end of today. So that's just on asynchronous work. Let me know if anyone has any questions about that. I'm happy to address it. All right, cool. Let's go ahead and review the essential questions that we thought about last time. So last time I had you all think about these 2 things before we got into the Desmos. First thing is, how in the world do we use a table to determine a limit? And how can I make connections between tables and graphs to kind of help us determine a limit? So those are the 2 things you want to think about. And then we're going to go ahead and log back into our Desmos. Now, it should be saved back to where we left off. Everyone should be, right? So let me go ahead and show you the code and where you're going to go ahead and log back into. Welcome. I saw that 2 people just came in. Yay. I'm so happy that we're getting more of you in. So Ernesto, you're here. And Cassie, yay. Awesome. Let me go ahead and submit the attendance. I went ahead and updated that in case you're worried. All right, so we are period 3. As a reminder, you're going to go to student.desmos.com and you're going to be typing in this code and it should put you back to where we left off yesterday. And please make sure you log into your Desmos. For those of you who probably missed out on the credit yesterday, you could get back that credit because if you just log in today, follow along, you could get your credit for the Desmos, and that would be awesome. So that we can all get our credit for this. All right, so we're period 3. Once again, make sure you log in. I'll hold this for a moment and I'm going to join you all in a second. All right, I hope I gave you all some time to get that. So I'm gonna go ahead and transition this over. So don't worry if you still need the code, okay? Because I'm gonna go ahead and put it in the chat in a second as well. So, whoops, this is not where I'm supposed to go. Yeah, over here, and we are period 3. So we're the second dashboard. Now, I'm gonna go ahead and copy this just once more so to make sure we're all on the same Desmos. Put this in the chat. Again, this is where I'll be recording credits. You want to make sure that you're logged in and you're following along with this. All right, and I think we left off on the 3rd slide yesterday. I forget. So we're going to see where we left off at. Awesome. So this is who we have logged in. We have about 16 students logged in. So again, you want to make sure that you're in here. And if you missed anything, right, feel free to go ahead and start filling out stuff you missed, right? If you weren't here the other day or you were not able to follow 100%, you could go ahead and go back and just fill those in. All right, I'll just wait a little bit for all of us to get in here. And remember, I'm going to, after, we verify we're all in, I'm going to anonymize the names. And that way I'll be able to give like open feedback as we work on this. All right, I'm going to click anonymize on the names. So we have some new names here on the side. And let me go ahead and see. So I'm thinking we left off on, yeah, I think we finished a little bit of 3. A lot of you, so just to kind of recap, for those who weren't here yesterday, very quick, we first did a little check-in about where we were as far as our energy levels. Then I guided everyone through this question here, number 2. It was a funky looking graph. The reason why it's kind of funky is because it looks like a nice straight line, but when you click right here where the X value is -4, there's an open circle. And most of you were saying that at this location, it's undefined. And let me show you all what you said. Shows up as undefined. So that was like the general consensus on that. So that's where we left off. So we left off on slide number 4. And I'm going to go ahead and take us to the next part, which is slide 4, I believe. I'm sorry, I was looking at slide 2, right? Yeah, sorry, I didn't talk about this one. The next thing I was asking you to do is to tell us what you thought the limit would be. And again, there was a consensus, and I'm on slide number 3 right now, just going over that. I went over slide 2 last. And you all agreed that the limit would be at -9. Because remember, we're looking at that Y value when we're talking about limits. And you want to make sure that if you're imagining bugs are walking, that they're coming in from the left and the right hand side. Because if you remember, according to our big ideas, that's when a limit exists. So super important, but y'all were correct here. All right, let us all transition to slide 4. Slide 4 is where we're at. This is where the game's at. So I'm going to go ahead and make sure that we are all here on slide 4. I'm going to start my screen restriction. So everyone's going to come with us to slide 4. Someone's still there in slide 1. Al Hazen. Cool. So we're going to now go ahead and start talking about how in the world do we estimate limit value. So limits are a tool to help determine function behavior first off. So limits tell us kind of like properties in the way a function is behaving. And tables, the thing that we're going to look at today, are tools that can help us determine limits. One thing about tables is that we can get something a precise estimate of the limit rather than just us eyeballing graphs. So, when using a table to approximate limits, it's important to create it in a way where you include both the right and the left hand side of the x value. We have to get really, really close to that x value, and we need to choose closer and closer points in order to get something more accurate. So, that's just a prelude or preview of how to actually create these tables. And now let's go ahead and transition to slide 5. So, I'm going to open it up 4 and 5. Let's all go to slide 5. You should have access to switch your slide. And what you see right here is basically a Khan Academy kind of written up explanation. So what I'm going to have us do is I'm going to have you take a look at this and read this on your own for about 3 to 4 minutes. And again, this is just me like kind of prepping you for like how to use your resources and how to first look through things, and then we're going to pull out questions. And I promise you, we're gonna get practice, and we're gonna know how to do this. But imagine we're asked to approximate this here limit. So it says the limit as x approaches 2 of this function that looks very funny, right? Because there's a division sign going on. Um, Another thing I want you to notice is usually when we write a limit, we always write f of x right after the limit. Well, in this case, you can also, by the way, you can also write what the function is instead of f of x, for those who are curious about why it's written like that. So the goal in this problem is they're trying to estimate the limit, and they're going to be using a table because this person doesn't have a graph. So they're going to decide to use a table instead. So if you look here at the steps, it's step 1, you're going to read through that. There's step 2, you're going to read through that. Then step 3. After you're done reading for about 3 to 4 minutes, I'd like you to go ahead and on your version, you see a little box. You're going to put what questions or wonders you have about the steps on using tables to find limits. So after you read through this, you should have a bunch of questions and wonderings, and then we're going to dig deep into this and apply it. So let's go ahead and read these steps, and for the next about 3 minutes. I'll be right here, and I'm going to put the directions back into the chat. For those who are still reading the steps and still processing, just go ahead and continue reading. I'm going to, at the moment just take a look at the questions and wonderings that are coming up. So you're free to also do that if you're finished, to see if someone else has a similar wonder or question coming up for them. And again, we have two of you who are on slide 4. And again, you want to make sure that you are, oopsie, logged in. You want to make sure that you're receiving your credit on the Desmos. So make sure you're logged in and following along with us. I mean, and otherwise, if you're having any issues, please let me know, and that would be awesome. All right. I'm hoping that all of us got a chance to go ahead and put your 2 cents here on slide 5. Again, for those who you want to make sure that you're in with us, the code is up here. I also put the link in the chat to make sure that we all have the opportunity to log on in here and get our credit. So let's go ahead and start looking at some of the questions and wonderings y'all are coming up with. This one's asking, so Ingrid's response is saying, I wonder what it would look like if we use constant increments. So I think by constant increments, kind of like 1, 2, 3, 4, would it mean we'll never get close to infinitely? And then like I noticed that too, right? Y'all notice how they says that you need to choose points that you have to simulate the feeling of getting infinitely close to 2. From here, step 2 is just from the left. So notice the x values. These numbers like 1.9, that number 1.9 is really close to the number 2. But you could find an even closer number, 1.99. And then you can even get closer from that, 1.9999. So each time, this is kind of like approximating what the limit would be, because notice we do have a problem at 2. At 2, for this particular function, the y value or the output is going to be undefined. So that's what this process is kind of doing. So first it did it from the left, right? So coming in from the left of 2, that means right below 2 is from the left. And then notice how these numbers right here are really close to 2, but they're above 2. So 2.0001 is a number that's larger than 2, but it's really, really infinitely close to 2. This one is less so, but it's still pretty close. This one even less so. So this is kind of like your limit coming in from the right. Because remember, everyone, that a limit is defined, remember, when the bugs are meeting up both left and the right. So that's why we want to make sure your table has both the left and the right hand side. Now in step 1 and step 2, they were only talking about the left side, see, to the left of 2. And then they kind of just tacked on the other side afterward. So let's see if anyone has questions about that, but I'm going to go ahead and go down and see if there's any other notices and wonderings that we should address. Okay, let me go ahead and clear my screen. Those were just little annotations for you. Okay. So now I'm going to scroll down and let's see what else. So this one's a good question. Will the limit you're looking for really be defined because it only gets close using decimals? Question mark. Someone honestly doesn't understand. That's okay. You could totally look at the steps and from there just pick something from the steps that doesn't make sense. I understand what's happening. I just don't get how this helps. It's a good question or a good observation for yourself. You're going to see once we actually put this into practice. And then why are we trying to get close to 2? What would x equals 2 be? So x equals 2 is undefined for this problem. So because the x equals 2 is undefined, we need to choose points that are really, really close to 2 in order to approximate the limit. So that's the answer to this here question. And there's a lot of wonderings here. Someone said something about this. Yeah, Al Hazen said, why did they kick out 2 for steps 3? Don't we need 2? Yeah, we do. To be honest, you all could have kept 2. So I don't know if you all noticed that too. Notice how the 2 right here was undefined. And they kind of just created the table without that 2 right there in the middle because 2 was undefined. So you could have added it there for yourself to say 2 is undefined. You could, but you don't have to. I mean, I guess they just excluded it because 2 is undefined. And 2 being undefined is not going to give us any information. And that's why they took the 2 out of the table. And what you have here are instead kind of approximations of what the limit would be. So if the limit is coming in from the left and it's about 0.25001, and the limit coming in from the left is going to be 0.24999, what I could do right now is make an estimate. I could make an estimate that the limit should be around, I would personally say that the limit for this problem as x approaches 2 is going to be around 0.25. Because I feel like this is approaching 0.25 from the left. And this is also approaching, from the left this way. This is from the right. It's approaching about 0.25. This is also from the left approaching 0.25. So I would say the limit would be 0.25. See, this is how I'd be using a table to make that estimate. So I would say this limit is this. So let's see if anyone has any additional questions. I did see something in the chat. So let me take a look. Okay, so someone says, so the answer will be 2.5001. The decimal place is in the wrong spot for that one. So I would actually say that both of these are approaching at about 0.25 from both sides. I'm going to pause for questions. Don't worry, we're going to get some practice on this. Or if there's a question you definitely want me to take a look at, let me know in the private chat, and I'm happy to take a look at your question. So again, notice how from the left and the right, the y values are approaching 0.25. Remember, when we're dealing with limits, you're always looking at what y value are the bugs approaching, or how is the function behaving near the y values. All right, I'm gonna go ahead and clear this up, and we're gonna have a check. So we're all gonna go to slide 6. Let's all go to slide 6. Now, here's a problem. Let's go ahead and see what y'all think. So there's these 3 students, and they were given some function, and they were asked to estimate the limit as x approaches 2 of f of x. Each student created their own table below. And this is what it says. Each table is actually accurate. Like, no one's going to tell you the table's necessarily wrong. They're accurate, but which one is the best table to approximate the limit according to what you read on the steps and what we just talked about? Which table would be the best? So go ahead and take your time on that. Again, we're on slide 6. So let me go ahead and move us to slide 6. So again, which student's table is the most ideal? And don't forget to follow by justification. Remember, that's what we're working on. in this module. We want to focus on justification, how to justify our work. So I'll give you a few to take your time on this, and then we'll check out what y'all are thinking. All right, so I'm going to go ahead and start checking out what y'all are thinking. So immediately I see the first three responses are saying table B, and I'm looking for that justification because remember, we want to focus on justification. Says B would be the best because it's using numbers very close to 2. I like that. Yeah, remember that's the idea. You want to come in close to 2. Notice how table B is doing that. So these 1.9s are all really close to 2 from the left, and these 2.01s are really close to 2, but they're on the right side of 2. So I like that. And then, so Gottlob right here, it says B because it gives you the closest results. I would push that if you want it, like, for example, I would say this is a developing, like, what do you mean closest results? Give us more details. Like this, if this was to be a mini final. So B because it starts in the 1 decimals and goes to the 2 decimals. I know what you mean, like decimal spaces or spots. Yeah, I get what you mean. And then the others don't go in the same detail. Yeah, I agree with you. I also want you all to notice how this table is like balanced. Like it's kind of like really balanced, randomly selected numbers. It's like evenly selected numbers, and it's kind of like growing in the same amount. Okay. And then B is best for approximating the limit. You want to push yourself to say, well, why is it the best one? Okay, I like this, what Henry wrote. Because it approached this Henri, I think this is Henri. If it's French, I don't know. It says B because it approaches, because I think we have a Henry here in this period. I'm not sure. Let me know if it's this period or my period 1. Okay, B because it approaches from the left, closest to 2, and also the right. I love this answer because you're talking about left and right. That means you're making a connection to our big idea. The limit only exists if it's approaching from the left and right. That's super important. So that's why I really like Henri's answer right here. I like it too. See, look at here. So Louis Hui says from both directions, left and right, trying to get as close as possible. I like this addition by going into decimals with the X values. So like kind of, you got to force yourself to use those decimals because they're going to give you a better approximation. And I like what Pierre said. I would choose B because it doesn't only show one side of the limit. It shows you all relevant numbers. So yeah, for example, if you chose C, that would be super incorrect. And the reason why C would be super incorrect, because notice that all of these numbers, 2.01 all the way up to 3, those are all numbers that are greater than 2. But remember, you also want numbers that are less than 2. You have to approach 2 from both sides. And this is only one side. It's only giving us one aspect. You need both sides for the limit to be defined. But all right, so it looks like all of us are in agreement that B is the best table here. And for those of you who are still stuck, you should definitely take a look at what everyone else here is saying, because everyone else is justifying this in their own words and they're all accurate and correct. So I would just go through and read these, especially if you're still lost, confused, and have some questions. And I really, really like Ingrid's because they're using actual numbers from the table. So I like this because that's their evidence. They're bringing in evidence in their justification. All right, y'all. Let's go on to the next slide. So we're all forced over to that next one. Okay, everyone. So let's try to apply what we just did. So this is going to be interesting. Your goal right now is you're going to try to find the limit as x approaches 1. So there's the question. What is the limit as x approaches 1 right here? The problem is you don't have a graph. See, it's blank. What you do have is a table. So it says there is some mystery function that you can't see right now. Your goal is you're going to try to figure out that limit as x approaches 1. So remember, our focus is we need to zone in on the x value of 1. What values do we need to choose to make that happen? You're going to go ahead and start guessing. The cool thing about this table, for example, let's say I put 7. It automatically tells me what the output is. So there is a function, but you just can't see it. So you're going to create a table to try to determine the limit as x approaches 1. And I'll give you some time to try that out. I'm going to then move over to my teacher mode and see what y'all are trying out. I'm going to be popping into some of the graphs to kind of give feedback or to maybe point out some very great responses. So let's all get in there, make sure we make our table. All right, I'm gonna continue working. I'm just gonna pop into a few to see what we got. Let me go into Gottlieb's graph right here. All right, so Gottlieb, I like that Gottlieb chose a value that's really close to 2 and below 2. So 0.999 is a number that's close to close to 1, my bad, not 2. 0.999 is really close to 1 from below, and 1.111 is a number that is close to 1 from above, but you can go closer and you can make your table more evened out. You could add more approximations to make this better. The answer is not 2, so I would double check that for Gottlieb. All right, let me see Pierre's graph here. I'm just choosing randomly. So again, so Pierre did something similar here. So something very close to 1 from below, and then very close to 1 from above. But again, you want to remember, if you want to kind of, according to the directions for the process of this, you want to make sure that you're simulating getting infinitely close. So if somebody gave me a table like this, I'd say that it is a developing table. Like, yes, you chose left and right, but you want to create the illusion that you're approaching infinitely close to the value of 1. So this is almost there. All right, let me check out Ingrid's over here. So similar thing, we need to make sure we expand our tables. Let me see, it looks like Carl's has a lot of points. So I'm gonna go here. All right, so I like this table. There's more values here. They checked the value of 1. That's cool. So at 1, the function is defined. And they checked it actually twice. So 1 down here again. They checked 1.99 and 1.5, 1.8. The only problem I have with this table is this is not coming in from below 1 and above 1. I mean, I do see some above ones actually right here, but what about below? You got to also approach 1 from below to double check, you know, whether or not the limit exists. So this is for Carl's feedback. Let's see Arthur. Right, Arthur just has 1 point. You got to add to this table, Arthur. Make sure that you're going back to our steps. So let me make sure. Sorry, my goodness, my bad about that, y'all. So I stopped the pacing. So I opened it up so that if you want to go back to the directions, your table should look like this, everyone. Your table should mimic this. You need to approach from both sides. It should not have just 2 points. You want to make sure that you're encompassing the definition of the limit when you're making your table. And according to the definition of the limit, we have to approach the number infinitely close. And how we do that is by setting up like this. So just as a reference, you should go back and try to re-edit your graphs. All right, so let's see Eta's graph, because I see some tables. So again, Eta's graph, it looks like you're trying to kind of graph the whole function, but we don't want the whole function. We want to find the limit as x approaches 1. So you want to choose your values that are below 1 and above 1. So really close to 1 from below and really close to 1 from above. So let's keep trying on it. Let me check Charlotte. Y'all, I love this table. So this is Charlotte Scott's graph. Okay, and the reason why I love this table is I could see the concept of the limit right here. I see this. So 0.99 is less than 0.99, and 1 is the value that we're interested in, right? The limit as x approaches 1. What is that y value? What are the bugs approaching? And it also has, like, yes, there's a repeat here, but we could just ignore that. We also have numbers that are above 1. So they're really close to 1, but they're above. And you could see that it's very evenly kind of spaced out. So there's 0.01, then 0.001, then 0.01, and then 1.1. So if this person was to try to estimate what y value the bugs are getting close to, I could clearly see that the bugs are getting close to the y value of 3 from both above and below. And again, this is encompassing the definition of a limit because we are approaching from the left and we're approaching from the right. This is a great table. So let's just make some adjustments to our tables. If you don't have something that looks like this, you shouldn't just have 2 points. All right, let me check out James Maxwell's. Yes, I love James Maxwell's graph as well. So Charlotte's graph was really good, but James is awesome. Take a look here. There's numbers approaching 1 from below. That's these first 3. So from below is another way to say from the left. And there's numbers approaching 1 from the right-hand side or from above 1. And as you can see, right, from above and below, right in the middle there, you can already kind of estimate that the limit is going to be equal to 3 from here. Because from the left, it's 2.99, really close to 3. From below, from above, it's like 3.02. which again, we can approximate the limit to be 3 because the bugs are approaching that y value. So that's what makes this nice. You could see the definition of the limit in your table. So that's feedback. Again, you want to make sure you replicate this. And yes, maybe you can't find your points. So that's another thing. There's the points. Yay, we found some. You might have to like dig in to find your points. So here are the points, and they're trying to, estimate what's happening near 1. And here's our x value of 1, and here are the approximations getting really close to it. So you're kind of like trying to create the pathway for the bugs to figure out what the limit would be. All right, let's check out Liui Hui. All right, good. I love this one too, everyone. Take a look at that. This table is great. I mean, just ignoring this part, that's okay. There's just an undefined part. I could see that from below, they're approaching 1. From above, they're approaching 1. Again, you could clearly see that the limit in this scenario is going to be 3. All right, y'all. So I gave some feedback, so I hope we made some adjustments to our graphs here as y'all were working. And we're going to go ahead and do slide 8, everyone. So let's do slide 8. You're free to move because I stopped my pacing, but I could paste it again just to make sure we're all following at the same spot. There we go. Okay, now for this one, you're gonna just now make some connections. So I went ahead and put the answer of an ideal table. And by the way, many of you had ideal tables. I pointed them out. But this one I kind of did extra. So this was a table I made. So I was like really approaching 1 from below and above, making sure my table was even. And I went ahead and I graphed what the function looks like. So this was our mystery function. It was a parabola. And what I'd like you to think about is what connections can you make with the table that's right here and its corresponding graph when it comes to the limit. And remember, everyone, the limit for this problem, the answer was 3, right? As you can see right here, they were approaching 3. The answer is 3 in this case. So what connections can you make with this here table and its full graph? Take some time to answer and submit your responses. All right, I'm just taking a look at your responses at the moment. Just a quick thing. I wonder why. So two of you are saying you think the limit is two, but remember, as x is approaching one, what y value are they approaching? Are you sure it's two? Because take a look at what's happening at x equals one. So that's for Pierre and Carl. So I was curious about the two. So as x is approaching one from both sides, what is the y value approaching is what you want to look at. So for those who wrote no connection, you want to definitely take a look at the responses from above and see if you can make sense of what others are making sense of when they're making these connections between the table, its graph, and what you could say about the limit. Just think about that. And it's okay if you don't see a connection, but you could totally see uh, what we're writing here. All right, so let's see. So I love this response. The limit is the same from both the left and the right hand side. Yeah. From the left, the limit is approaching a y value of 3. From the right, the limit is approaching the y value of 3. So because the left and the right hand limit are meeting up at the same spot, the bugs do meet up. And someone said that. Who said the bugs? Someone was saying that. I saw someone mention bugs. Yeah, Carl said. Some connections I can make from this graph is that the bugs do meet up. So yes, that's also true because take a look at your graph. There's no gaps in it. Like obviously there's a pathway for the bugs to definitely meet up. There's no gaps. They're not able to fly or jump, so they will indeed meet up. I could see that connection. And I don't see how the limit would be expressed on the graph. So for James, if you had a graph, we would do it the same way. So remember y'all, when I would annotate my graph. So I don't see it, the X value of 1. It's like probably all the way down there. I would draw a vertical line down. I would place a bug to the left, to the right and to the left, and the bugs would move and they would stop at the X value of 1. And if you were to see what that X value at 1 would be, it would be at the y value of 3. So that's how you would use the graph if you had the graph and not the table. You would just do it the same way we've been doing. Imagine the bugs walking and they stop at the x value of 1. See how high the bugs are. All right, I love that these here, Sophia and Henri, they're adding lots of detail to their justification. I like that they're saying that they're equal because the left and the right side and they meet up. And it would make, I like that Henri is making sense with the graph being a parabola. It makes sense, right? That it is a parabola. I like this. I like this. So I think originally, you know what I like about Louis Hui's response here? Because initially I think Louis Hui put, I'm confused. I don't know what I'm being asked. But then after taking a look at everyone's responses, this person made a really deep connection. So that's what I like. Like they adjusted it. It's all about, adjusting your thinking. Like, it's fine to do that. You want to adjust your thinking. That's the juice of it. So the limit is shown more in depth in the table, while on the graph we can't see it clearly. That is like really, really good. I really like what was said here. Table is better for a better exact limit. That is like hands raised, an awesome connection you made. And it says the limit for 0 is the same on both graphs on the table. Just want to lend us our focus. So the limit as x approaches 1 was the question we are being asked to find. Good. I like that you adjusted this, that they meet up at the y value of 3. You could see in the table, look how it's approaching 3 from the left and the right. All right. So because due to our timing, we're going to go ahead and pause here. We're going to be continuing to finish this off on Tuesday, the next time that we meet in class. And, we're going to finish this up and then we're going to move on to our next train of thinking. But other than that, we actually don't have a checkout question. We did have one at the end of the slides, but that's okay, y'all. I don't want to take up more of your time. Let's pause here and I'll see you all soon, all right? Bye, everyone. Enjoy your day. Thank you for all your hard work. Bye. This was great. Enjoy. If I don't, bye. If I don't see you anytime soon, I'll see you all next week. Or text me and remind if y'all have any questions. I'm happy to also help on the asynchronous. Bye, everyone. Let me go ahead and end this meeting so I could upload it and record it.